Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is distinct fun. The problem difficulty is easy, and you need to know bitwise XOR as prerequisites for this problem. Let's have a read at it. You are given an array A of length n. In one operation, you may choose a prefix of array of length k, that is, all the indices between 1 to k will be affected. Now we also choose an integer x that is going to be greater than or equal to 0. And then we apply bitwise XOR operation to all the elements in this prefix and make AI to be equal to AI XOR with X. Our goal is to make all the elements in the array as pairwise distinct using the minimum number of operations. So we are choosing a k length of prefix, and for all the elements between 1 to k, we are going to transform it into AI with the XOR of X. X is also of our choice and it is greater than equal to 0. Let's see the input format. We have t test cases, and for each test case we have two lines. The first line contains the integer n, that is length of our array. In the second line we'll have n spaced integers that are a1, a2 till an. As for the output, we simply have to output the minimum number of operations required to make all the elements in our A as distinct. As for constraints, number of test cases will go from 1 to 10 raised to 5. Length of our array will go from 2 to 10 raised to 5. And the elements in our array will go from 0 to 10 raised to 9. Let's see some sample inputs. So for the first sample input, the array has two elements, 0 and 0. So let's say we simply choose the prefix of length 1. We choose 1 and we do a XOR with, let's say, element 1. So if we do XOR of 0 and 1, the answer is 1. So now our array transforms into 1 and 0. And both the elements are not equal, they are distinct. So it took us one operation to do this. For the second sample input, we have three numbers 0, 1 and 2. Since they are already distinct, there is no need to make any operation. So the answer is 0 as the array is already distinct. Let's see how we can implement this or how we can approach the solution. So before that, let's see what are the operations of XOR. So let's say we have the bits A and B and we'll see what is their XOR. So if both the characters are same, the XOR is 0. If both the characters are not same, that is they are different, the XOR is 1. So 1 0 and 0 1 will give us a XOR of 1. But 0 0, right, and 1 1 will give a XOR of 0. So with this, let's see what we can do. Let's assume that our array starts something like this. We have some number x, then we have y, then we have z, and then let's say we again hit x. Now here we have a problem. We have to choose now a prefix so that we can change it. Our goal is to change it so that we don't have same numbers, right? So if I choose a prefix till here, now both x will be there. If I do any kind of XOR, x will be affected same, right? So if I perform XOR on these two numbers with any number, the resultant will be same. So I cannot choose this as my prefix. So what we can do? We will have to choose a prefix that is just short of the number that is repeating or that is duplicate. Now we have to perform some XOR so that this number becomes different from this. Now there are any number of x that we can do to perform this XOR, or in this case, let's say any number that we choose to perform the XOR so that it becomes different. But this will pose a problem that as we keep on going further, there can be other numbers that might be same as this. So how can we avoid this? So if you see, the number in our array A will go from 0 to 10 raised to 9. Now as we have seen, if the original bit is 0 and we do a XOR of 1, it gives us 1. So if let's say to a number, I add some number, let's say 10 raised to 100. If such a large number is added, what will happen? Since we know that the number that we already have, 10 raised to 9, is very small than this. So whatever bit this is, whatever bit this number will have, will be very far. A better example would be, let's say 2 raised to 100, right? this will be a single bit, right? This will be a single bit trailing with lot many zeros, like 100 zeros, right? So what will happen if we have any number that we're trying to do a XOR with? The original number that we have will have the bit 0, right? And we have this bit 1 here. Essentially, what will happen is whatever this huge number that we are doing XOR with, right? It will simply become 2 raised to this big number plus whatever AI or AJ that we have, right? So on and so forth. Since we do this, right, if we do this to these three numbers, it will make sure that any number that we have in to the right now will not be equal to this because they are limited to be less than equal to 10 raised to 9. Now our challenge is only to make sure that now this x already exists to find whether there exists any other x. Similarly, if let's say there are more numbers, there are a, b, c, and we again hit a, now again we can simply choose to do prefix. Again we can choose all the numbers, and now we can simply do the XOR with, let's say, 101. Again, since the AI will have the bit as 0 at that position, when we do the XOR, it will be simply as adding it to that. Since we are not actually concerned with printing these numbers, we just have to find the number of steps that we have to take. So simply what we can do is, we can keep going through our array of numbers. Once we find any number that is duplicate, we perform the operation, or you could say that we increment the count, right? This is our resultant, right? We increment the count by 1. Again, we keep finding until we again find a duplicate and keep on incrementing the count until we exhaust and we have gone through all the elements in our array. At the end, whatever is this result that we have, that will be our solution. That is the number of operations that we have to take to make sure that all the numbers in our array are distinct. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of our n and our array. Now once we have this, we initialize an unordered map so that we can find if we have hit a duplicate number. Then we start going through our array. Once we go through our array, if the number does not already exist, we add it into our map. Now if the number already exists, what we'll do is, we'll choose a prefix just before this number to a XOR with a large number, let's say 2 raised to 100 or something like that. Once we do that, all the numbers from 0 to I minus 1 are now going to be distinct from any number in our array. Since that is the case, we can flush out our map and just include the current number. We keep on doing this, and once we receive any kind of duplicate, we increment the count of the operation that we have just done. At the end, we print this count, that is the number of operations that we did, and as you can see, I've got an AC in my C++ implementation. Let's see how we can do this in Python. Similarly, in Python also, for each test case, we call the function solve, takes the input of n, then our array. Once we have this array, we traverse through it and we store the numbers in a dictionary. Once we hit a duplicate number, we increment the count of operations by 1. As we have gone through all the numbers, at the end, we have the minimum number of operations required to make all the elements in our array as distinct. And as you can see, I have got an AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.